Hey everyone, today we're learning about saving and loading data in 3 different ways. So I want to show you one way that's a little bit slower, a couple of ways that are a little bit faster, and then talk about the pros and cons of each method. So let's start off with the simplest way to save and load data. First, let's set up a quick scene, and we just want something that is really simple. I'm just going to add in a text, and I want to center my text. So I hold Alt-Shift, put it right there in the middle, center, and I just want this to track a score. So it's going to be a really simple text score, and it'll track a score. Now we're going to simulate this score going up by pressing the space bar. So we need to have some kind of script in our scene, and we'll just create an empty and call this scoreIncreaser. That's really all it's going to do. This script needs to have sorry, I gotta actually create a script. This object needs to have the script. So I'll call it scoreIncrease. We'll edit it, and then we want to save the score in Unity. So we're gonna need a reference to a text. So don't forget to add your library up here, the namespace up here at the top, UnityEngine.UI. Public text scoreText, and then we also want to have some kind of int, and in the start function, let's just say score equals 0. I mean, that's really not necessary, but we'll start at 0. And then an update, if Input.GetKeyDown, KeyCode.Space. Sorry, I'm using a new keyboard, so it's kind of hard for me to hit the keys that I'm normally used to. Then we just want to increase the score by 1 and reset our text to the new score. Simple as that. This by itself will not do any kind of data persistence. For us to really test persistence, we need to have either a second scene or a reload, or something like that. Looks like we forgot to add the script onto the object, so let's just go ahead and do that real quick, and then refer to our text and hit play. So we press space, score goes up. The reason why you'd want persistence is, let's say they get this score and then they exit out of the game and they come back. You want them to still be at 16. So we want that to be our goal. I'm going to show you the first method to do this. Now this is the least safe in terms of, like, if you want your game to be honorable, if you want people to not try and cheat and things like that. The least safe method is using something called PlayerPrefs. So we can type in PlayerPrefs.setInt, because this is an int. And then we have to give it a string. So we're going to call this scoreInt, and then we have to give it a value, which in this case will be score. So every time we update the score, we're also going to update this PlayerPrefs value. PlayerPrefs is, like I said, it's not the safest value. This is more reserved for settings. So if you want them to be able to set up their resolution and their volume and their key bindings and things like that, those are the things you'd really want to use PlayerPrefs for. You don't want to use that for actual gameplay elements. But we're going to go ahead and do it just to test things. Now in the start method, we probably want to, instead of saying score equals 0, we're going to say if PlayerPrefs.getInt scoreInt is not equal to 0, then we just want to say score equals PlayerPrefs.getInt scoreInt. Let's just change that to null, because even if it is 0, who cares? We'll take 0. I guess it's never going to be null. I don't know. All right, we'll try 0. Whatever. It doesn't like us. So we'll try that now. Hit play. And immediately you'll see it works. So we're at 14, exit out of play mode, enter back into play mode, and we're going to be at 14. Did I not do that right? Oh, I didn't set the text. All right, so now we'll see the score on the screen. If you were looking before, the number did change. We just didn't see the text because we forgot to update it. So we can start off from wherever we left off, real simple, and this will be data persistence. You know, we'll be at 25 again, but the problem is it's not very safe. PlayerPrefs is highly not recommended. So let's get into the second type of persistence. If you do want to use PlayerPrefs, this is great for settings and key bindings and things like that. Next type of data persistence is it's really actually saving a file. Now for this, you got to add 3 lines over here to the top using system, using system.io, and then using system runtime serialization formatters binary. So you add those 3 lines, and now we can create some save and load functions and a save and load class. Now we want to create a separate class, and we'll call this, I don't know, just score container. It's really not going to do a whole lot. We'll have a public int score. Do make sure that all of your variables in this class are public so that they can be accessed from other classes. Okay, so we'll call this public int score, simple as that. Not a whole lot. And then in our MonoBehaviour, scoreIncrease, instead of doing all of this, we're going to create a save and a load function. So we'll create public void save. It doesn't even have to be public at this point, just public void save, and then public void load score, and we'll call save right over here. And then we'll load the score on start. So our script will look a little bit simpler in the start and update functions because we're going to write all of the meat of things down here. So for load score, we'll get to that one second. Let's start with saving. So we'll do the same things. We're going to increment our score, update the text. We don't need PlayerPrefs anymore because we're not going to use that. Instead, we're going to be using a binary formatter and do some serialization. So we'll start by creating a binary formatter, and that's equal to a new binary formatter. We're going to start from scratch. We'll create a file stream. Oops. Let's just call this file equals capital file dot open application.persistent data path plus, and then I want to give this part of the path, I'm going to put score container.dat. Now a DAT file will not be something that a person could easily create. Now we do have to do file mode.create. So kind of a long line here. If you want, you can press enter and just bring it on to the next line. This will still be it'll still act like one line of code. Just makes it easier to read. Okay, so now we need to use our actual score container class and put that right over here. I'm just going to call it SC, and this is going to equal score container bf.deserialize and then file. Simple as that. And then we're gonna, oh whoops, what am I doing? This is part of the load function. So we created our file. The next thing we want to do is create a score container. SC is a new score container. And then we need to say sc.score equals score. not clock scanning, coefficient score. And after that, we can pretty much serialize it and then close it. So bf.serialize file sc, and then file.close. So that's saving. It's kind of a lot to do, but once you get the hang of it, you can just do it over and over and reuse this code in all of your projects. This part is interchangeable, the type of class, but that's all there is to it. Now when we're loading, we're kind of doing the same thing, but we change a couple of things around. So we're going to make another binary formatter. You know what, I'm just going to copy a couple of these things. One difference is when we open the file, rather than doing file mode create, we're going to use file mode open. When you're loading, you do want to check if the file exists. And for that, you use the path. And if it exists, then you'll actually do everything. So now that I've created my file stream, this is where I want to do score container. sc equals score container bf.deserialize, and then we're going to use our file. And now we want to do file.close because we don't need it anymore. And we'll say score equals sc.score. So it's a little bit backwards down there at the bottom. Basically what we're doing is we're using our binary formatter, change this into a binary file at that path. And when we're loading, we're opening the file. When we're saving, we're writing the file. And we need to tell the file what to have. So we use our container class. We store all our values, serialize it, close the file. When we're loading, we're doing the opposite order. We're creating our class from the file, and then closing the file, and then just resetting our values in this script up here, the score. So we've written our save and our load, and what this will do for us now is it will allow the data to persist by using a file. Now you'll notice there is an error. Our class is not marked as serializable. So I did this just to remind you that you have to put above your data class the serializable tag, and then everything will work after that. We have an end of stream encountered before parsing was completed. I think I have a corrupt data class saying there's a sharing violation. File access. Oh, okay, there we go. Now everything's working. Yeah, I had a corrupt file because I tried to save it too early. So we're starting at 27. I'll hit play again. Should be at 27. I did not update my text when I loaded things, so I might even want to put like scoreText.text equals score plus score, but otherwise everything's working. So this is a second method. This method works pretty well. One thing you need to be aware of is you cannot save and load in the same frame, and you can't like save or load in update. So if you want to autosave, make sure you do it every so many frames or every so many seconds. It's definitely not something you do in update because it's a pretty slow operation. I like it because it's more secure. You can't really read a data file, and then it's hard to edit, I guess, but it is a slow operation, so it's definitely not something you can do every frame, so don't try and do that. All right, the third type of data persistence is another simple one, and it has benefits and it has drawbacks. It's using a singleton design pattern. So this type of data persistence will let you go from scene to scene, but it won't let you go from one time playing the game to whenever you reload. So let me create a new scene here, and I'll just call this one scene 2. So all we want to have on scene 2 is pretty much the same stuff that we have here. So it's just, you know what, I'm just going to delete it. I'll go File, Save As, and then make it Scene 2. So now we have two scenes, and Scene 2 will be identical to Scene 1. We're going to get rid of this save and load stuff. Instead, we're just going to take the fun stuff and put it in. So we'll just increase our score and update it. And then in the beginning, we don't need to load our score. So I'll just get rid of that. What we're going to do here is add another statement. This time, if we press the A key, let's go to Scene 2. So we need to add a statement up here at the top using UnityEngine.SceneManagement. This is good for if you have multiple scenes. Sometimes you want to go between one scene and the next and keep track of the score or money or points or something like that. But like I said, it does not persist any data beyond that one game session. So if you want to have something from game session to game session, use one of the first two methods in this video. If you want to have something just from scene to scene, you can use the Singleton design pattern instead. So if we press KeyCode.A, we're just going to go SceneManager.load scene, and then we'll load scene 1, which will be the second scene in our build. So we will have to go to our sample scene real quick, and then go to build settings and just add this, and then go to scene 2 and build settings and add that. And so now if we go back into our sample scene, we're going to have our, oh, you know what? I need to go Save As, Scene, Sample Scene. There we go. Okay, so now our sample scene has everything the same, including our score. If I press play, and I press space, and then I load the next scene, my score is going to be 0, right? So we want to have that score persist even when we change our score. And if I press space, you can see it restarted. So we're going to use a singleton on our score increaser. The way that you do that is in the class itself, we're going to create a reference to a score increaser. And I usually just title it with the initials of whatever the word is. That's just my own method, or you could have whatever you want to name it as. But that's what I generally do. And we want to make this static. So when you make a variable static, it can be accessed from other scripts. And what we want to do in the, not the start, but the awake function is say si equals this. Now, if you only use it once in the project, then you don't have to add any extra lines. But if you really wanted to, you could say if si not equal null, si equals this, else destroy this. I mean, if you really wanted to, you could do that, but it's not necessary. So, sorry, if si equals null. That'll prevent you from having multiple. If we really want it to be a singleton, you can only have one. Okay, so now we're going to go onto the text object and add another component. We're going to create a new script, get score from singleton. And it's going to be really simple. We're just going to put something in the start function. So ScoreIncrease.si.score. We need a reference to the text. No, we'll do it like this. ScoreIncrease.si.scoreText equals get component text, not text alignment. I need to add using UnityEngine.UI. And then we'll update our text. using the score from the other script. Yeah, I think that's about it. So this will let us use the singleton to persist data across the scene. On the singleton, really important, we have to say DontDestroyOnLoad this. And we really want to say this.gameObject. So what that'll do is it will prevent us from destroying the game object when we load the next scene. Otherwise, we would destroy the game object in the next scene. So what you'll see is we're going to have a second scoreIncrease game object, but it's not going to have the component on it when we load the scene. So let's go ahead and try this. We'll hit space a few times. So we got a score of 8. Press A. And now our score is 0. Our text is missing. Did we save it? I think we did. Our score is still 8. Our text has not been updated. Oh, we did in the wrong scene. Okay, that makes sense. So let's go to our scenes. On scene 2, we'll need to have our text get updated. Okay, so let's go back to scene 1, hit play, spacebar a few times, press A, and you'll notice there will be a second score increaser. One of them will have the component, one will not. Okay, so now we're in scene 2, as you can see. The new score increaser, it deleted its own component because of our singleton design. The old score increaser now has a reference to the new text in scene 2. So that's pretty cool. We were able to keep our score and display it, and then we can hit space and it keeps going up just like we'd expect. So that was it. Those are my 3 methods. Think about which one works for you. I'm going to go over a recap real quick. The first method was using PlayerPrefs. It's great for settings and key bindings and things that aren't really that important and don't need to be secure. The second one is saving a data file using a binary formatter and serialization. The third method for data persistence is not for like in between play sessions, but just in between scenes, that you can use a singleton design pattern. I have heard it is not recommended to use DontDestroyOnLoad, and instead you should create all of your singletons or all of your managers and then load scenes additively on top of that, but that's a more advanced topic. So I'm not going to introduce that right now. For right now, this works, and it pretty much does the exact same thing. In my opinion, I think this is easier, and this is what people should be doing. Anyway, that's it, and I'll see you guys in the next video.